Okay, I'm looking at number 14, and this is definitely a harder factoring problem. And the reason I say that is that my trinomial it does not have a coefficient of 1 on my variable squared term. My leading coefficient is something besides 1. I'm looking right here, just so you're following. Right here I have a 4. Okay, and factoring is considerably easier when you have a 1 right there. Okay, my first suggestion, if you listen to my last video all the way through, the last problem I suggested this was we try to get rid of that number. Can I factor? I didn't suggest it the same way, but do all the terms have a common factor? We should always look for that, especially when you have a coefficient besides 1. So my first goal is, can I actually pull a 4 out of all 3 of those terms? In other words, can I divide all 3 of those by 4? I'm literally thinking divide by 4, divide by 4, divide by 4. And we get kind of lucky here because all 3 of those terms are actually divisible by 4. So I'm going to rewrite the whole problem, and I'm going to rewrite it as 4 times quantity. And now I'm going to put my new term, 4's cancel, a squared. 28 divided by 4 is 7a. Still have a positive sign because I had a positive right here. Minus 72 divided by 4, and I believe that is 18, if I'm doing my math correct there. Now, I'm not done. Did I factor it? Yes, I factored a 4 out of all of it. But now let's go back to what we did at the top of the page, and what we have right here should look exactly like any one of the problems you did where you were factoring a trinomial with a positive coefficient of 1 for my highest power term. So the 4 just gets carried down, and now I'm going to look to make my 2 parentheses here. A times a giving me a squared. We should be okay with that by now. Multiply to get negative 18. If you need to do some work over here, multiply to get negative 18. I've got negative again, so one of each sign. I've got 6 and 3. I've got 9 and 2. I've got, what else do I have? 18 and 1. Did I miss anything? And I'm going to try to get a 7, but it's going to be a difference. Okay, I'm adding, but in the process of adding, I'm adding a positive and a negative. Since, again, I have a positive right here, I'm going to make one of my signs, I'm going to make my sign of my bigger number positive. So I've got positive 6, negative 3, positive 9, negative 2, positive 18, negative 1. Add those up. 6 minus 3 is 3. 9 minus 2 is 7. 18 minus 1, don't care because bingo, I got it right here. So the 9 and the 2, put a minus and a plus to match your signs with the numbers you had. And that would be considered right here my final factored answer for what we started with there. And we also saved ourselves a lot of work. You'll find out when I get to 21 how things can get a lot more complicated if I can't get a 1 in front of my variable squared term, because sometimes it's not possible. Okay, so what happens when it's not possible? In other words, look at 21. There's a leading coefficient of 7. First thought is, can I get rid of that 7? But the only way I can get rid of it, of course I can't just delete it, that'd be nice, is if I could divide all of these terms by 7. And last time I checked, 61 and 40, neither one of them is divisible by 7. So, nice thought, no good. What am I going to do? Plan B. A lot of you probably learned this as a method. We call it the AC method. We call it the product sum method. There's a whole bunch of different names for it. So I'm going to walk you through it. Okay. The reason that I think a lot of people call it the AC method is that you start, when you make your little T-chart, essentially, that we've been doing, our product here, our multiplying, is A times C. So we're going to multiply A times C here. In this case, my A times C, A is 7, C is 40. So 7 times 40 is giving me an answer of 7 times 4, 280 for my product. This number, the 61, still goes right here. So this is still my B value, is what we call it when we look at this as AX squared plus BX plus C, A, B, and C being my coefficients. Okay? Now, I'm going to go ahead and do those numbers. Notice I didn't put any parentheses underneath it because I'm going to have a little bit more work here. Let's go ahead and get some numbers that multiply to get 280. I'm going to start with the easy one. I know 10 and 28 multiply to get 280. 10 plus 28 gives me 38, not 61, so that's no good. So other numbers that multiply to get 280. Going to have to do some work here. Let's see, we should be able to divide by 5. So I should be able to get 5 and 42. No good. That's going to give me 47. So that's no good. Let's do, I could do 10, 28, 4. Let's do 4 and something. 4 and 70. 74. No good. Getting there, maybe. 6, 7. I should be able to divide by 7. 7 and 7 is 40. That's what we had up here. 7 and 40 does not give me 61. 8, 9, 10. Might be helpful to have a calculator at this point. I'm trying to do some mental math, not so quickly. 20 and 28 divided by 2 is 14. 14 giving me 34. No good. Tough one. We just got a lot of numbers here. 7, 4. 4D. Did I do that? I did 40. Did I do 5? 28 divided by 5. I actually am going to pull out a calculator. Maybe 6. Did I try 6? Let's see. 280 divided by 6. Nope. I actually have it. 5 times 56. Okay, I just did some bad math here. 5 and 56. Sorry for the hold up there. 5 times 56 does give me 280. I did some bad math there. 5 plus 56 gives me 61. So those are my two numbers that I'm picking. Good thing that that works because nothing else was working out there. Okay, now the difference is I'm not just going to throw those in the parentheses over here like I had been doing, where I would put those at the end right here. No good. Okay, instead what I'm going to do is I'm going to actually rewrite my entire trinomial here. 7n squared, leaving a blank for the middle, plus 40. And what I'm going to do is I'm going to split up my middle term. Instead of writing plus 61n, I'm going to write plus 5n plus 56n using the two terms that I have right here. Okay, and by the way, you can do that in whatever order you want. You could have done plus 56n and then plus 5n. Now what I'm going to do what I call factor by grouping, and here's where it's going to start to look like factoring. I'm going to take, sometimes people like split it down the middle, I'm going to take the two terms on the left and factor them. Now the only thing I can pull out of those is an n. Again, this is common factoring. We can't pull out any number. Divide by a common number. So I've got 7n plus 5, still in parentheses. Distribute back through and you should get 7n squared plus 5n. Factor this. I'm going to pull out, not an n this time, I'm going to pull out a 8, I believe, is the biggest one, but let's check. 8 times 7 gives me 56. I need an n with it, and 40 divided by 8 is 5. Okay? Notice, parentheses should match. If they didn't, you did something wrong. 7n plus 5, 7n plus 5. That becomes one of my factors, is that matching parentheses. And the other one, any guesses? Comes from the numbers out front, if that's what you were thinking. We've got an n and we've got an 8. There's no minus sign, so it's a plus if it's not negative. N plus 8. Okay, and that would be my final answer. So we're basically turning it into a factor by grouping problem when you have 4 terms and you split them and factor the first 2 and then the next 2. That's what we call factor by grouping. Okay, great method if you're looking for a method. You could, I'm just going to mention it, do this problem completely by guess and check, get the same answer, but it's going to take a little bit more guessing and checking because if you notice the middle terms, it's not just a matter of 5 plus 8 adding to 61. It's 5n plus 8 times 7n, 56n, giving me the 61n. Okay, I'm going to leave it at that. Use that kind of problem for whenever you can't get a coefficient of 1. Try a couple on your own and see how they go. Good luck.